Multicast addresses, what are they? They're simply a one-to-many address, such as if you were doing a video conference, for example, you will use the 224 range of IP addresses to send or stream one packet to many different hosts within that range. So that is what a multicast address is. Okay, now we're seeing the private IP addresses. Now let's take a look a little bit closer at the multicast addresses. Now, multicast addresses, we really don't have much to do with them, but we need to understand them. Now, there are specific types of multicast addresses. These are not the only ones you see on the screen, but these are the ones you're more likely going to get tested on it. Routing protocols such as RIP, EIGRP, or SPF both use multicast addresses in order to send their updates to their neighboring routers. Where previously the other versions were broadcast in type, now is multicast. RIP for IP version 4 uses the 224.0.0.9 for its multicast address to carry traffic from one router to the other. In IPv4, in IPv6, it uses the FF02:9. In IPv6, which will be a later lesson, FF, anything that starts with an FF, is a multicast address. So that is the multicast address for the new version of RIP, which is RIP-NG. For EIGRP is 224.0.0.10. That's what it uses to carry the data across from one router to the next using that multicast address. In IP version 6, you see that they're all FF02. The last one, though, it says A. Because in hex, 10 is A. That's why in IPv6, for the newer version of EIGRP, is A. Now, SPF is the only little bit different one that it uses two different types of multicast addresses. And what are they? The 224.0.0.5, or for IPv4 and IPv6, it would be the FF02:5. And it says standard routers. What does that mean? Well, once you get to OSPF, you'll see that OSPF runs elections, right? The non-designated routers or the non-backup designated routers, when they pass information along, they will pass it along using this particular multicast address. But if you are a designated router, or DR, or a backup designated router, you will send your data across to other routers, your packets, through the 224.0.0.6 multicast address to separate that so they know from where it's coming from. That will be the only difference with OSPF. Now, for the newer version of OSPF, obviously it's in hexadecimal, which is OSPF version 3. But it's important to know this because when you are analyzing to see what's going on, you're doing a debug on a router, you're looking at different addresses, you're seeing what's going on behind the scene. If you're seeing a 224.0.0.5 or a 224.0.0.10 or any one of these multicast addresses that you see in front of you, know that that's what they are. They're not your neighboring router's IP address or anything like that. That is the IP address where your packets are being carried from one router to the other. So these are the multicast addresses that you really need to be aware of for your certification purposes, even in real-world scenarios.